mixtures. There are two main types of mixtures, heterogeneous and homogeneous. Yeah, suspensions are definitely heterogeneous. So, heterogeneous are mixtures that are unevenly mixed. Hetero meaning different. So, the way to think about it is it's like grab a cup of trail mix. Okay, yeah. So the point is, no two cups of trail mix are going to be exactly the same. Whereas a homogeneous mixture is going to be evenly mixed. Homo here means same. You pour 2 cups of Kool-Aid, pretty much the same. They're mixed the same so that there's the same amount of sugar and all the stuff inside the Kool-Aid. Okay. Examples of homogeneous mixtures, the things that we've been talking about so far, are solutions. So all of our calculations with our dilutions and everything have been looking at solutions. Sugar water, salt water would be solutions. The aqueous types of mixtures that we've been doing calculations on, all solutions. Okay, but there's also something called a colloid, which is also a homogeneous mixture. Milk is a colloid, homogenized milk anyway. And so the big difference is that in a colloid, the particles are bigger. Because they're bigger, they're able to scatter light. Particles.
Why does your C look like an R?
Because I'm
Good, that's why.
So, if you think about like Windex or Kool-Aid or anything like that, they may have a color to them, but if you have them in a clear glass, you can still see through them. The light still goes through. Yes, there may be a color, a hue that filters out some of the wavelengths of light, but it doesn't scatter them.
And a flavor. Some of it's flavor. No, like some blue ones are like the flavor of the Windex. No, I'm talking Kool-Aid.
Flavor. I think
what is the flavor of Windex? Ammonia.
Anyway, whereas a colloid like milk, I mean, you hold it up, it's not just that it has a color, the light gets scattered, it doesn't go through, you can't see through, even if it's in a clear glass. Fog would be another example of a colloid. So think about driving in foggy weather, the light doesn't, these are high beams because the light doesn't get through, it gets scattered. Okay.
Dust.
Huh?
Dust.
No. Yeah, I mean, a dust storm, that would be more of an example of a suspension. Okay. What was I going to say? Oh, heterogeneous mixtures. This would be suspensions. Okay. And for suspensions, we have large particles it's going to settle out over time. Okay, so certain types of salad dressings that you have to like shake because it's an oil-water mixture. That would be an example of a suspension. Over time it settles out, so you have to shake it up before you use it. Muddy water would be an example of a suspension. Over time all the particles fall to the bottom and separate out. And so all the things that we're going to talk about today are going to be examples of one of these types. Well, we're mostly going to be talking about colloids and suspensions, I guess. The big thing about suspensions is that they can be filtered. Now, milk is an interesting case because actually milk is a suspension. That's how you get cream and stuff like that. You let the milk settle and the cream rises to the top. But what they do is they homogenize it. So processed milk, they take it and they basically blend it so that they break up the fats into really small globules, and that makes them so that they're small enough that they will turn into a colloid. They don't settle out over time. They get mixed into with store-bought milk. It's always homogenized.
Eric's got cream and physics off. Cream, yeah. And he's like, no, it's a cream. I'm like, Rick, you go to a milk silo and you want cream, you don't turn on the agitators, just go climb to the top and dip in to get it nice.
Yep. So solutions of colloids don't settle out because the particles are small enough there. They just stay suspended. All right, we're going to look at some examples. Foam is a mixture of a gas into a liquid. So, you know, like shaving foam can, there's a liquid that's in there, and the way the can works is it lets air in, the nozzle lets air in as it squirts it out, and mixes it in. That's why you can get so much foam out of a single can. But mixing it in, then it traps it inside the liquid molecules, and you have a mixture of gas and air in the liquid that creates this big foam. And that's why when we looked at marshmallow is another example of a foam. That's foam. Where's my marshmallow? There's a foam. Okay, a marshmallow. In this case, it's we have a foam that we're a gas and a solid, but that gas that's suspended in there, we already saw during the gas laws, we could change the pressure on it, change the volume of it. It's the air inside that's being compressed and.
So does this mean we get to eat whipped cream and marshmallows?
No.
You get to eat shaving cream.
No, I'd rather not.
So, any of the foams that you see, with the cappuccino, or this is an interesting case with the ocean. I mean, there's no soap here or anything. It's just the way that the ocean comes in. It integrates air into the ocean water and creates this big foamy substance. He just is in Bangladesh.
He just came out of there and he's wondering what year it is.
So, you can create a foam by suspending a gas in a liquid or in a solid. And these types of substances, whether it's used for padding or a lot of people have mattresses that have foam in them nowadays. It's all just created by taking that that substance, and when you're setting it from a liquid into a solid, you incorporate gas molecules, air bubbles into it. Okay, an emulsion emulsion is where you suspend one liquid into another. So mayonnaise is an example of an emulsion. You were making mayonnaise. So what do you make mayonnaise out of?
I know you use egg whites.
Eggs and oil. So you're suspending one liquid into another. Yeah, right there.
Well, not really long.
Yeah, just, that looks unpleasant.
Well, it's just mayonnaise.
It doesn't look like mayonnaise, it looks like pattern.
Well, you guys are probably so used to Miracle Whip, which
No,
is not
I hate
mayonnaise.
it. That's gross. Oh, Miracle Whip is
It's
way
so
better
bad.
than mayonnaise.
Milk, store-bought milk is also a emulsion. It's an emulsified, the whole homogenization process. Again, they just basically blend it. Okay, so foams, emulsions. Next thing we're going to talk about are aerosols. An aerosol is where you have a liquid that is suspended in a gas. And so fog and clouds are examples of aerosols. Just tiny little water droplets that are suspended in the air. But we usually hear the term aerosol referred to in these types of substances.
Yes.
They can. So,
You want to kill someone? Get that in
aerosol cans work a little bit differently than the foam cans. The foam, they're incorporating the air into the liquid as it comes out. Here, they're just spraying through pressure, spraying the liquid out so that it becomes a mist, an aerosol in the air. So, air freshener would be
that ass can.
that.
Is that for the spray little ass?
Not by just a can on aerosol.
You know, I'm
You
pretty
can
sure.
buy Chicken Death Wish.
Okay.
So that's the most camping stuff. You know, is he using a mixture of mustard gas and chlorine?
Yes, that would be an aerosol.
Yeah.
Smoke is solid mixed into a gas. So that's fairly obvious. Off the end of a cigarette, tiny little solid particles float in the air off of a fire out of the back of redneck trucks.
Or
Just the trucks.
Or just a piece of truck.
No. That's not a redneck truck. That's a flag truck.
Okay, and then we have sols or gels are examples of solids that are suspended in liquids. Paint would be a sol. Okay, but of course paint is a suspension, which is why you always have to stir it or shake it before you paint anything, because it will settle out. The mixture of the paint will settle out over time. It won't paint correctly. Okay, another example of a sol is blood. And there's another example of a suspension. If you let blood sit long enough, red blood cells will sink to the bottom. White blood cells will kind of get in the middle of the plasma and rise to the top.
Blood. Ketchup. It's like, after you don't shake it, you turn it upside down and get really.
Yeah, I guess that does settle out over time a little bit. Examples of gels: Jello, obviously, but also certain types of other gels, hair gel, that kind of thing. One thing You guys know where they get the collagen?
Bone, bubble,
Yes, they grind up animal bones to make the stuff that actually sets up the jello. Okay, this diagram, or this picture shows what's called the Tyndall effect. So here we have a laser light. We can see that laser light go straight through the solution. So this would be a mixture of like salt water or something like that. And so the light goes through, it doesn't get scattered at all. But in the colloid, and I'm not sure what's mixed in here, the light gets scattered and we can see the beam. The laser light should go in a straight line. You should never see it unless it bounces off of something. So here we see the light bouncing off of something in the colloid. That's what we call the Tyndall effect. That kind of can tell the difference between a colloid and a solution. But you guys have all seen the Tyndall effect before. You ever seen light streaming through a window? Little dust particles in the air will scatter the light.
So our air is
Yes. Our air is definitely now, as far as the gases, they're homogeneously mixed.
right.
Right? But as far as the fact that there's particles and all sorts of stuff that are being suspended in it, yes, it is overall a heterogeneous mixture.